practice. Let's see. Let's see.
Send this in to you on email, or
You can text me pictures, you can send it via email, whatever you want to do. Good morning, guys. Sorry, we've had,
Good morning.
the computer has been lagging. So anyway, it's finally gotten connected. But anyway, we were just talking about, we were passing back chapter 7 stuff. So if you have anything for chapter 7, you need to send me whenever you get a chance to do it. You can email it, you can upload it, you can text Alec the stuff that you turned in to me yesterday. I will send you back your chapter 7 test for corrections, and we will work on that.
Okay,
So alrighty, so what we're going to do is let me get my book. We're going to be back in chapter 8. So we left off with on chapter 8 on page Okay, we left off on page 475, so that's where we're going to start today, is page 475. At the top of the page. All right, so we've been talking about similar figures, and what did we say? How are similar figures different from congruent figures? What's the main difference? Not the same size, good. So we talked about how angle measurements are going to be the same, but length of segments are not going to be the same. So similar means that they're the same shape, same angle measurements, but they are not going to be the same segment lengths, okay? So let's go ahead and take a look. Real quick, let's back up for just a second to page 473. That's what we were just talking about. We also talked about when we are naming similar figures that we look at our corresponding information. A big part of what we're going to be working on is corresponding placement. Okay, so when I'm looking at my polygons and I look at how a polygon is named, we can see at the very bottom of goal 1, right above example 1 on page 473, it says that if we have quadrilateral or polygon ABCD is similar to EFGH. We talked yesterday how when I'm looking at corresponding angles and sides, A would correspond to E, B to F, C to G, and D to H. So when I'm looking at my sides, side AB corresponds with side EF, okay? So remember that that's what we've got to pay close attention to how those polygons are named and how they correspond to each other, okay? That helps us to identify the corresponding sides and the congruent angles, okay? So let's go ahead and take a look at theorem 8.1 on page 475. Theorem 8.1 tells us that if two polygons are similar, then the ratio of their perimeters, so think about, I set up a fraction of the perimeters of each figure, is equal to the ratio of their corresponding side lengths. So I can take the perimeter of each figure, one is in the numerator, one is in the denominator. How do I find the perimeter of a polygon? What do I do to all the sides?
you add them all together.
Add them all together. So I'm just adding up however many sides. It could be a triangle, a quadrilateral, it could be a hexagon, pentagon, whatever it is. I'm adding up all my sides together to find the perimeter. So I can put the perimeter of one in the numerator, the perimeter of the other in the denominator. So then when I set that equal, when I make a proportion, I show that the corresponding side for my polygon in the numerator, I put the corresponding side in the numerator of my proportion. Denominator will have the side that corresponds with the perimeter in the denominator of the first proportion. Okay, so when we look at example 5, now one of the things that I had you guys do yesterday that I think is going to be super helpful, it is for me, because again, y'all know that I'm not a very visual person, I'm very concrete. I need to actually, be able to see what my connections are. So if we look at example 5, notice it says quadrilateral JKLM is similar to quadrilateral PQRS. So again, if I'm trying to compare sides, it helps me to trace my sides with my finger. So if I'm looking at JK, I would run my finger from point J to point K, and I know that JK is going to correspond with PQ because of the order that the letters are written in. Therefore, I can go from JK, and then the other one I can go from PQ, and I've actually been able to concretely look at what side corresponds with what. Then I can also find that JK, my segment is 10, PQ is letter Z. Okay, so I know that I've got JK is 10, PQ is Z. So then I look at my other sides that correspond that are labeled. So I can see that KL, so when I trace KL down, I can see that that side length is 15. And then the corresponding to KL is going to be QR. So I can trace that down, and that is 6. So then that helps me to set up the proportion of, well, I got lotion on my hands and I can't get the lid off. There we go. All right, so we said that the first one we looked at, the example they give in the book is KL over QR is equal to JK over PQ. So when I'm looking at KL, what is the measurement of KL? 15 over, what is my measure of QR? 6 equals, what is JK?
10.
Over, what is PQ? Z. So again, I could have set this up several different ways. I could have done QR over KL, but then I'd have to have PQ over JK. I could do JK over PQ, then KL over QR. So just know the main thing is I want to make sure that whatever this side measure is corresponds with the other one, okay? And whatever I have in my numerators, I match, I make sure that those are corresponding in my denominators. Or these two, we can also make them correspond figure by figure. So it's totally up to you how you set it up. There's multiple ways. But here I'm going to have 15Z is equal to 60, divide by 15, divide by 15, and Z is equal to 4. That way, I know that that one side that is equal to 4, the corresponding side is equal to 10 because they are similar figures. Any questions about that? The biggest thing to remember about this section, number 1, is proportions I solve by cross multiplication. Next, when I set up proportions, I'm putting that something over something is equal to another item that corresponds. I want to pay attention to my order so I can figure out my corresponding sides, plug in the information that I need. And that's about it. Now, the only other thing is if I had to give the length of a side and it wasn't just the single variable, then I may have an operation that I have to perform. Like if it was 2Z, then I would find Z and then multiply by 2. But let's go ahead and look at guided practice on page 475. Guided practice, page 475. It's at the bottom below theorem 8.1. All right, if two polygons are similar, must they also be congruent?
No.
No, we just talked about that they are going to have congruent angle measures, but that's the only thing that's going to be congruent about them. So let's go ahead and look at number 2. Decide whether the figures are similar and explain your reasoning. So let's look at number 2. I can see that I've got 2 rectangles, and let's take a look, okay? With figure 1, what side corresponds with my side measure of 15?
3 out of 10.
Okay, so in number 2, my first side is 15, and we said that the side that corresponds with that is 10. What is the side that corresponds with 8? 3. Cross multiply. I've got 10 times 8 is 80. 15 times 3 is 45. Does 80 equal 45?
No.
So, are these corresponding? I mean, are these similar? They are not, because they're not proportional. Okay, so by cross multiplying, these two do not equal each other. So these are not similar figures. Let's look at number 3. Number 3, what do I know about angle measures of similar figures? Similar figures, what about their angle measures? They're equal to each other. Angles are congruent. So let's take a look, and we can look and see where in figure 3, my small figure, my top left angle is 89 degrees. What is the top left angle of figure 2? 89 degrees. What is the bottom left angle measure of the first one?
82.
What is the bottom left measure of the other one? 82. So going along with this, and also, what is my top right angle measure of my second figure? 102. What is my, what do I know that a quadrilateral, all the angle measures are going to equal? 360. So what I've got to do is I've got to figure out, is 102 the number of my missing figure in the first one? So if I have 89 plus 82, 87, and then 102, 9, 10, 11, plus 7 is 18, 19, 20, put down my 0, carry my 2. 8 and 2 is 10, 10 and 8 is 18, 18 and 8 is 26, put down my 6, carry my 2, and I've got 360. So I can see that the missing angle in the first one is 102 degrees. My missing angle in the second figure is 87. So for both of those, I do have similar figures because all of my angle measurements are congruent. Let's look at number 4. List all pairs of congruent angles and write the statement of proportionality for the polygons. So let's take a look at number 4. What does angle A correspond or is congruent to? Notice we're using the diagram. TUVW is similar to ABCD. So angle A is congruent to angle T. Angle B is congruent to angle U. Angle C is congruent to angle
V.
And angle D is congruent to angle. Good. What side corresponds with AB? What side corresponds with BC?
UV.
What side corresponds with CD?
WV.
Okay, so which comes first with CD? What should come first? What corresponds with C?
VW.
VW. So we want to make sure that our order goes in the same way. And AD corresponds with
TW.
TW. So notice each of these that we've said are corresponding sides. That would be AB corresponds to TU. BC corresponds to UB. Okay, so when we're saying these, the way that you would write that is as a ratio, and they're all equal to, all the ones that we just said, we would list them out. Okay, so if it says list all the pairs of congruent sides, or the proportionality of the figures, you're putting what side corresponds with the other, the side of figure 1 to figure 2, corresponding sides for each figure. Number 5, find the scale factor of TUVW to ABCD. So let's think about this for a minute. Scale factor means what? A scale factor is going to be a ratio, okay? So notice, what sides did we say, what side does AB correspond with?
TU,
TU. What is the measure of AB?
9,
What is the measure of TU?
15.
Okay, so 9. Okay. Why did I do this backwards? What did I mess up on? What did the directions tell me?
Should it be TU over AB?
It should be. Why?
Because that's what comes first in the pair.
In the problem,
Yeah.
in the directions, they said find the scale factor of TUVW to ABCD. So that means whatever is first has to go in my numerator. So if I'm looking at TU, then I've got AB. So what is the measure of TU?
15.
What is the measure of AB?
9.
What would this be as a reduced fraction?
Oh, 5/3.
5/3. So this is considered my scale factor. So my reduced fraction, whatever my sides, when I put up my corresponding sides, but I have to pay attention to what order they've told me to in the problem. So I know TU corresponds with AB, which is 15/9. I could pick any two sides in this situation. Look at the other sides that we have. We don't have. Yeah, we do. Nope. They didn't give us any other two sides that are corresponding. Okay. So that was the only one we could use in that situation. All right. So we said the scale factor is 5/3. We could also write that as 5/3. They both mean the same thing. So if my scale factor is 5/3, it says to find the length of TW. All right. So if I've got TW, what side does that correspond with?
6 AD.
Okay, TW is going to correspond with AD. Okay, so I don't know TW, right? But I do know AD. So what is the measure of AD?
6.
6. So how can I use my scale factor here to figure out my sides? What can I do there? I'm going to set up a proportion. So I have x/6 is equal to 5/3. I don't know this one. I do know AD. My scale is 5/3. How do I solve a proportion? Cross multiply. What is 6 times 5?
33.
And 30 equals 3x. So what does x equal? 10. So looking at my scale factor compared to the side I'm looking at, because remember we said every side is going to have the same scale factor. That means that every side, when I set up a fraction with a numerator and denominator, it is going to reduce to 5/3 in simplest form. Okay. All righty, so then number 7 says, find the measure of angle TUV. So let's take a look. What angle does TUV correspond with?
ABC, but he has a 70-degree angle.
Okay, so let's take a look at that. So I'm looking at angle TUV is similar, is congruent to angle ABC. How can I find the measure of angle ABC?
It's 9 plus 6. No.
Now we're talking about angle measures here.
All right.
What kind of figure do I have here? I've got a trapezoid, but what do those two side marks tell me? No, not that they're parallel. They're congruent. So what kind of trapezoid do I have? What kind, huh? Isosceles trapezoid. Remember, if I have two congruent sides, it is isosceles. What did we learn several chapters back about the base angles of an isosceles trapezoid? The base angles are what?
Equal to 180.
No, my base angles are congruent. What is the angle on the bottom right of my figure?
70.
70. So what is the bottom left?
70.
70. So I know my base angles are congruent. I also know that means my top angles are going to be congruent. So if my base angles are each 70, what are my top angles going to be?
70.
No. Remember about what would my top angle be with this bottom angle?
Oh, 110.
Why?
Because I something next to 180.
Huh? Why don't you think about something for a minute? If these went out and this went like this, and I turned it into parallel lines with a transversal, what do I know about consecutive angles? If they're consecutive,
Oh,
what does that mean? They equal what?
180.
This angle here plus this angle here equals 180. Remember, consecutive angles equal 180. So if this one is 70, this one's 110. So when you said 110, you were right, but I wanted you to know why you're right. It's because consecutive angles add together to make 180. If I were to extend these lines out, it's the same as having parallel lines with a transversal. Lucas, please put that away. So here I can find that if this is 70 and this is 70, then this is 110 also. Okay, so the main thing we had to do here, not only do we have to look at what kind of figure I have, understanding and remembering about base angles being congruent, knowing that I said that's a property of isosceles triangles, also knowing, not isosceles triangles, isosceles trapezoids, also knowing that when I have a transversal with two parallel lines, I have consecutive angles add together to equal 180. So see how we've pulled information from numerous chapters back and put it all together in this situation, okay? So your homework for this section is going to be, you look at the bottom of your notes for 8.3, if you haven't filled in your notes, for 8.3, it says theorem 8.1, if two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. Corresponding side lengths. And the last thing says to draw an example of similar figures and show the ratios of the perimeters is equal to the ratios of the corresponding side lengths. So basically, I'm asking you to draw the figure in the green box for theorem 8.1, write out KL plus LM plus N plus NK over PQ plus QR plus RS plus SP is equal to KL over PQ, LM over QR, MN over RS, and NK over SP. Okay, so that's what you're filling in at that last part of 8.3. Your assignment, pages 476 to 477, 9 through 41 odds, mixed review, 479, 53 through 67 odds. Remember, we worked yesterday on talking about when I am completing my homework, I can go back to the examples in that section to help me if I get stuck. Go back and look at the section to figure out what to do. Yes.
I'll put out more notes. Okay.
Awesome. Okay, great. Thank you. If you'll just come there, that'll be great. All right, and then mixed review on page 479. Go ahead and take a look at that. Notice that the first section, finding slope. I am given two ordered pairs and I need to find the slope. What is my slope formula? M equals. No, slope formula. All right, what goes in the numerator? Y2 minus Y1 over X2 minus X1. I'm finding the difference of the Y's over the difference of the X's. If you were planning on taking the ACT, that is on it. You need to know that formula. Finding angle measures. So again, in these, we're dealing with angle measures of a triangle. What do the interior angle measures of a triangle equal?
180.
So I'm going to add angle plus angle plus angle equals 180 and solve for the unknown. Look at the last part, solving proportions. You're just going to cross multiply to solve for the unknown. Okay. Moving right along, 8.4, we are moving to similar triangles. So we just looked at similar polygons. Now we're specifically focusing on similar triangles. All right, so again, we're going to go back. We're going to be pulling back some of this information that we've seen before about properties of triangles. It says in this lesson, you will continue the study of similar polygons by looking at properties of similar triangles. The activity that follows example 1 allows you to explore one of these properties. So in the diagram, this is example 1. Triangle BTW is similar to triangle ETC. Which angle corresponds with angle B?
E.
Angle T?
E. Right?
Angle T. Look at your order that they've written it. I have BTW and ETC. B and E are my first letters of each triangle. What is my middle letter of each triangle? T. And then the last letter is W, so that corresponds with C. So basically what I have here is I've got two triangles in one. I have a larger triangle that has a smaller triangle in the top. These sides are still going to be proportional, okay? So if I'm looking at, let's go ahead and take this. So I have, let me erase. So we just said I have triangle BTW is similar to triangle ETC. Okay, so the first thing says, write the statement of proportionality. How many sides does a triangle have? 3. So how many statements of proportionality do I have to have? 3. Okay, so I know that side BT, actually, what is BT going to correspond with?
E.
And actually, I'll go ahead and put BT
In the book,
corresponds with ET.
in the book, it has it the other way.
Yeah, and so, but I mean, the main thing is if I have BT first, and that's what I don't understand, is why they put BTW first, but then they put ET in the top, because I like to keep it, because
Right.
remember, we've talked about how whatever comes
Does it
first,
matter which way?
it does not matter. What does matter is that we keep them in the right order. So as long as I have my triangle, one triangle in the numerator, one in the denominator, it's fine either way. So BT corresponds with ET. What does TW correspond with? TC. And then what does BW correspond with?
EC.
Or we could say WB. If you want to go BT, TW, then WB, that would be fine too. And so WB would correspond with CE. Same thing, just E. If you name it BW, it's EC. Just pay attention to your ordering, okay? All right, so we said, so this was letter A. Look at letter B. Letter B says find the measure of angle TEC. So let's take a look. What is the measure of angle TEC? How could I find the measure of TEC?
This is 34.
Okay, well, that's angle T. Remember, that would be ETC. Okay. Which angle corresponds with TEC?
B.
So TEC is congruent to what?
B.
Okay, to angle B. And what does angle B equal?
79.
79 degrees. Okay, so angle TEC is congruent to 79 degrees. So the measure of angle TEC is going to be 79 degrees. Is everybody good with how we did that?
Mhm.
I had to look at my corresponding angles. In this one, I did not know the measure, but I did know the measure of angle B. So because they are congruent, then that's the measure. Now let's go ahead and look at letter C. Find ET and BE. Okay, let's use the information that we know here. Okay, what do we know in this situation? What do we know about side CE? CE equals 3, right? So if I know CE equals 3, what side corresponds with CE? WB. And what is WB? 12. Okay, so I've got 3 over 12. What is ET? Okay, ET is our unknown. So I'm going to let that be X. And so then what is BT? 20. Now, so we've looked at the two corresponding sides, EC over BW is equal to ET over BT. What I want you to do for a minute is, like I said, it helps if I said, hey, I know I've got this side here is going to be congruent to this side here. Because notice, positioning wise, these are both the same. These are going to be corresponding. So when I look at the measure of this side, it corresponds with the measure of this side. When I'm looking at my teeny tiny triangle, I know that the measure of ET, this little teeny tiny one, is going to correspond with this whole side of my big triangle. So I said my little triangle base is 3, my big triangle base is 12. My little triangle side or leg is unknown, but my big triangle leg is 20. Okay, so again, if you have to literally go across with your fingers to figure out what corresponds with what, also paying attention to the letters that you've been given. How am I going to solve for X? I'm going to cross multiply here. Okay, so 12 times X is 12X. 3 times 20 is 60. So what does X equal?
5.
X equals 5. Okay, so ET is equal to 5. Now we've got to find BE. Okay, what side corresponds with ET?
BT.
BT. Well, think about ET as part of BT, right? What is the whole side measure of BT?
20.
So if BT is 20 and I subtract ET, which is 5, what is the side BE?
15.
15. Good. So I use what I know. I know the whole entire side is 20. We just found the smaller segment was 5. So 20 minus 5 is 15. Any questions about that? Okay, now for 81, we are starting with postulate 25, angle similarity postulate. This is where we start with our notes. Angle or AA similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Remember, we're talking about angle congruence here. Doesn't necessarily mean the sides are the same. But if two angles of one triangle are congruent to two angles of another triangle, I have angle similarity. Okay. So it says, draw the example of AA similarity postulate and write the statements of congruence and similarity. So basically, you're going to draw the pictures that we have in the box. I have two triangles. I can see that angle K is congruent to angle Y. So I've used a single arc there. Angle J is congruent to angle X. So I have a double arc there. And then I have my if-then statement. If angle JKL is congruent to angle XYZ, and angle KJL is congruent to angle YXZ, then triangle JKL is similar to triangle XYZ. So earlier in the year, we talked about congruence. We talked about congruent triangles. This time, we're talking about similar triangles. But we can use the angle postulate just like we did for congruent, but in that situation, the side links had to be the same for them to be totally congruent. Now we're just similar. All right, go ahead and take a break. If you have questions when you're online, be sure to just unmute and let me know if you have a question or if you need me to repeat something. Okay, guys?
Yes, ma'am.
Yeah, no, he has a nice trade.
Chapter 6 directions and.
Thank you, dear. Okay, so there is that. I need to find copies. All right, I'll make a few copies and I'll be right back.
I'm gonna walk by Bro, you have an idea how much of high class Garrett. Garrett.
Yeah, what's up?
It's about to teach it high class. Bro, what if I enable chat for next week?
Do what?
I said, what if you enable chat?
Oh yeah,
How bad
I
that would
don't hit people back on the chat. It's like once I send it out and somehow like it got sent by everybody.
Are they like-
I just don't trust.
Did April die or something?
Was she even on there?
No.
Dude,
Bro, Zach got.
Bro, my
exposed
brother-
too. What? Zach Chinlet got exposed too, apparently. He's not gonna, so he can't take a
Oh.
lift tonight.
my brother was,
I'll get a ride or
my
something.
brother.
I don't even know if I'll be back.
Garrett,
Hey, you wanna go?
No,
You don't wanna go?
well, no, I don't know if I'll
bro,
be back home
dude,
in time.
people have really good words on you. Bro, if you just read the table,
That. They used to have
bro,
like
Yo, I
Garrett,
thought of it.
somebody
My-
drew
my
a
brother-
very good
let's get
marshmallow.
on. Was he on Zoom and he was in Walmart? So he joined and he
Hold on,
texted
sister.
his friend on Zoom. He said, "Yo, I'm in Walmart." He sent to everybody. He's like, "I'm joking."
When you whole class in the walls.
That's a very good.
Alrighty,
figure.
so I do not know if the bell will be ringing. There was nobody in the office, so.
We can ring it ourselves.
Yeah, it can be your own bell. Alrighty. So, everybody good? All right. So we just looked at our angle postulate. We have, example 2, proving that two triangles are similar. Color variations in the tourmaline crystal shown lie along the sides of isosceles triangles. In the triangles, each vertex angle measures 52 degrees. Explain why the triangles are similar. All right, so it says, look, if you look at it, it says because the triangles are isosceles, you can determine that each base angle, there we go, is 64 degrees. Okay, so remember with isosceles triangles, my base angles are congruent. With an isosceles trapezoid, we looked at in the last section, we also found that base angles are congruent. So in this situation, I have two isosceles triangles. That means the base angles are congruent. Therefore, using the angle-angle similarity postulate, you can conclude that the triangles are similar, okay? So we knew that the vertex angles were 52 degrees. So that means my two bottom angles are going to be the same degree measure. What are the 3 degree measures of a triangle? Total, added together, 180, okay? So remember, if they've told me, if I know that the total equals 180, and I know that one of those angle measures was 52 degrees, then I know that 52 degrees plus 2 times x, because remember, it's two base angles, they're the same measure. So take away 52, take away 52. So 2x is equal to, what is that, 148? Divide by 2, divide by 2. So x is equal to 74 degrees. Okay, so that's how they did that. No, that's not right. 64.
Wait, what?
No, wait, what did I do? I
74
subtracted wrong.
right?
This should be 138. So 64 degrees. Sorry about that. All right. No,
No,
128.
69.
No,
No,
hold up. 180 minus 52. Look, I'm gonna have to go old school. 10, 8, 7. So now I have 128. Now 128 divided by 2. Half of 12 is 6 and half of 8 is 4. 64 degrees. All righty. Y'all know I can't do much in my head. I mess it up every time. All righty. So we had to know 3 interior angles equals 180. We had to know that isosceles triangles, my base angles are congruent. So I subtract the angle that I know. Then I have to take that, divide by 2, because my 2 base angles are congruent. All right. Underneath that, it says example 3, why a line has only one slope. It says use properties of similar triangles to explain why any 2 points on the line can be used to calculate the slope. Find the slope of the line using both pairs of points shown. Okay, so we can see our red line. We can see I have points A, B, C, and D. I can calculate slope by going from A to B, by going A to C, or A to D. I can use any 2 points and reduce my fraction to simplest form. And so every time, whether I use point AB, I can use from A to B, I can go from B to C, I could go C to D, I could go B to D, I could go A to C, it does not matter. Any 2 points, start to finish, I put it in my slope formula. When I plug in my points using M equals Y2 minus Y1 over X2 minus X1. Every single time I put in the ordered pairs, my slope is always going to be the same. So we can see from the example of what they did at the very bottom of 8.4, they put in the slope of 2 points and they found that my slope is 3 over 2. Now remember, if I'm given exact points, I can also count my slope. And so you can see that's what the blue lines are here. And I could see if I had grid lines and I could count, I could say, hey, how many am I going up and then right or left? Or am I going down and left or right? Whatever I can, so I can count my slope going from point to point, or I can use my slope formula to plug in my values. Any questions about that? But the reason my slope on the H line has 1 slope is because no matter what 2 points I choose, when I plug it in, it will always reduce in simplest form to the same values. Let's look at goal 2, page 482. Using similar triangles in real life. All right, because I'm always taking aerial photos. All right, aerial photography. Low-level aerial photos can be taken using a remote-controlled camera suspended from a blimp. You want to take an aerial photo that covers a ground distance of G, of 50 meters. Use the proportion F over H is equal to N over G to estimate the altitude H that the blimp should fly at to take the photo. In the proportion, use F is equal to 8 centimeters and N is equal to 3. These 2 variables are determined by the type of camera used. So they just told us the proportion I'm using is going to be F over H is equal to N over G. Now, what do I know about, let's look at what they said. Okay, so G is what? They said G is equal to 50 what? Meters. What did they say to use for F? What centimeters? 8 centimeters. And what did they say to use for N? 3 centimeters. Now, think about this for a minute. Do you remember what we talked about yesterday about when I'm setting up my proportions? I want to make sure that I have my numerators have matching units. So in this situation, F and N, it's okay to keep them as centimeters. Okay, so I can keep as long as they're in the numerators. So I'm going to have 8 over H is equal to 3 over G. I'm going to go ahead and label these, not G. I can plug in 50 meters. Okay. So I'm going to cross multiply. So I have 3 times H is 3H is equal to 8 times 50 is going to be what? 8 times 5 is? 8 times 5 is? 8 times 5 is 40. So 80 times 5 is 400. Divide by 3, divide by 3. How many times will 3 go into 400? It won't go evenly, will it? So 3 into 400, 3 will go into 4 1 time, subtract, and I've got 10. 3 will go into 10 3 times. 3 times 3 is 9, subtract, I've got 1, bring down to 0. Okay, so I know that I'm going to end up having this, right?
Repeating.
I'm going to have a repeating decimal, so when I write my solution, what am I going to have to do?
Oh, John.
Okay, so in this situation, I can just go ahead and say, instead of having, when I talk about my distance measurement, I'm not going to say, well, you need to be 133.3 repeating meters in the sky. Okay, so I'm not going to say that. I'm going to go ahead and round that and estimate that to be 133 meters. Okay. So I want to go ahead and estimate. That's why I have my little approximation symbol instead of it being equal to. Yes.
Why don't you have to turn 50 meters into 2 meters?
Because in this situation, now you could if you wanted to, but with proportions, as long as I have like measures in my numerator and like measures in my denominator, then I can work with what I've got, okay? If you wanted to change centimeters to meters or change meters to centimeters, you could, okay? Now, obviously here you're gonna be given decimals, so it would be better to change. So you could change it if you wanted to, but you don't have to, okay? All righty. It says in lesson 8.3, you learned that the perimeters of similar polygons are in the same ratio as the lengths of corresponding sides. This concept can be generalized as follows. If two polygons are similar, and this is our next bullet point, if two polygons are similar, then the ratio of any two corresponding lengths, such as altitudes, medians, angle bisector segments, and diagonals, is equal to the scale factor of the similar polygon. Okay, so now we're looking at, it doesn't necessarily have to be just a corresponding length of a side. It might be an altitude. You remember when we talked about altitudes and medians and angle bisectors, diagonals, all that good stuff. So I can actually use those lengths that are corresponding to find the scale factor of a polygon. So let's look at example 5. You can see that we've got, basically, I've got two inverted triangles, and I can see where I've got that line, the blue line down the middle that shows that I've got a perpendicular line that's intersecting at 90 degrees. I can see that in my top, the very top of my figure from N to M is 12 and M to P is 12. So what is N to P?
24.
Good. When I look at my bottom and I say R to S is 8 and S to T is 8, what is R to T? 16. Good. Now I can see that the length of my line that is perpendicular. So basically I can look and break that top triangle into two separate triangles and have that side that's corresponding. And I can see that measure is 6, but I don't know what the other measure is below it. All right, so it says find the scale factor of triangle NQP to TQR. I'll start with that. So I'm gonna go ahead and write that so I make sure to keep everything. Okay, so we're finding the length of the altitude QS. Find length of QS. Okay, and so we know we have triangle NQP to triangle TQR. All right, so when we're looking at corresponding sides, what did we say NP was? Segment NP equals what?
24.
24. And we said segment TR is equal to what?
16.
16. Good. So how can I write that as a proportion? 24 over 16. Good. We said NP corresponds to TR. That means 24 is my numerator, 16 is my denominator. Huh?
Can't you simplify that to 3 over 2?
Okay, so eventually we're going to get there. Okay, that's what that's the whole thing we're looking at is we've got to find the scale factor. So that simplifies to 3 over 2 because what do you divide both of them by? 8. Good. So now because the ratio of the lengths of the altitudes is equal to the scale factor, you can write the following equation. So when I look at my altitudes, I can see that one altitude is QM, the other is QS. What do I know that QM is? 6. What, so I'm trying to find for QS. What is my scale factor? 3 to 2, right? Cross multiply. 3x equals 12. So what does x equal? So we know that QS equals 4. So the first thing I had to do is I had to use 2 corresponding sides to find my scale factor. Then I apply that scale factor to my other 2 corresponding segments that I need to solve for an unknown. So I'm having to do 2 steps here. Use corresponding sides to find my scale factor. Use the scale factor to use my missing side. Any questions on that? All right, so let's look at the guided practice on page 483. 483 guided practice. If triangle ABC is similar to triangle XYZ, AB equals 6 and XY equals 4, what is the scale factor for the triangles? 3 over 2, because I would have 6 over 4 is what they've given me for my 2 corresponding sides. 6 over 4 reduces to 3 over 2, so my scale factor is 3 over 2. Look at number 2. It says the points A, 2, 3, B, -1, 6, C, 4, 1, and D, 0, 5 lie on a line. Which 2 points could be used to calculate the slope of the line? So I've been given points A, B, C, and D. Which 2 of those points could I use to find the slope?
A and B.
A and B. What else? Any 2 of, any combination of the 2. I could use AB, BC, CD, AC, AD, CD. I just picked 2, okay? So any 2, when I plug it in, I'm gonna be able to find the slope. Number 3, can you assume, what word is that? Taboo, right? We never want to assume if we don't know anything. So basically, when you read, can you assume, just automatically think no, unless the rest of what you see proves otherwise. Can you assume that corresponding sides and corresponding angles of any 2 similar triangles are congruent?
No.
No, because sides are not necessarily congruent unless my scale factor is 1 to 1. So think about if I had a scale factor of 1 to 1. So look, if you think about this one's 3 to 2. If I have a scale factor of 1 to 1, then that means when I have a side of 24, this side's 24. When I have a side of 12, this side is 12. Okay, so 1 to 1 means my numbers are exactly the same and one as the other. So that means they're going to be congruent. The only time that they're going to be congruent is when I have a scale factor of 1 to 1, and that means that they're exactly the same size. All right, let's look at numbers 4 and 5. We are having to determine whether triangle CDE is similar to FGH. Okay, so let's look at triangle CDE. What is the measure of angle C? Number 4, 39. What is the corresponding angle of C?
F.
Angle F. What is the measure of angle F? 41. So are these similar triangles?
No.
No, the angle measures have to be the same for them to be similar. Look at number 5. I have triangle CDE and I have 2 base angles of 60 degrees. What is angle D going to measure?
60.
Why?
Because all angles have to equal 180.
The angles add together to make 180. And what kind of triangle is this if all 3 angles equal 60 degrees? Not equilateral. Lateral means sides. Equiangular. Good. So if all 3 angles are each 60 degrees, it is an equiangular triangle. So I can see I've got 2 angles that are 60 degrees in CDE. I've got 2 angles that are 60 degrees in FGH. Therefore, I know that each of my missing angles are both 60 degrees. They are similar. In the diagram shown, triangle JKL is similar to triangle MNP. Find the measure of angle J, the measure of angle N, the measure of angle P. What is the measure of angle M?
37.
It is 37 degrees. Which angle corresponds with angle M? Angle J. So what is the measure of angle J?
I don't know.
Huh?
I know.
No,
I'm
37
very
degrees.
sorry.
They're going to be the same angle measure. Okay. Look at angle K. What is the measure of angle K?
90.
90 degrees. Which angle corresponds with K? N. So what is the measure of angle N?
9.
90 degrees. Excellent. What is the measure of angle L?
53.
53 degrees. Which angle corresponds with L? P. So what is the measure of angle P? 53 degrees. Okay. Look at number 7. Find MP and PN. Okay, so I'm starting with, what is the measure of MN? 8. So what side corresponds with MN?
JK.
JK. Hold on a second.
Just kidding. It's not JK.
JK, LOL. Okay, so we said that MN corresponds with JK. And what did we say the measure of MN is?
8.
8. And JK is? 4. What would that reduce to? 2 over 1. Okay, so remember we want to keep it as our, that's our scale factor. So now if I need to find MP, what side does MP correspond with? MP corresponds with JL. So I know that MP is what I'm looking for. What is the measure of JL? 5. So now I'm going to apply my scale factor of 2 to 1. 5 times 2 is 10. X times 1 is X. So JL is equal to 10. Now we need to find, not JL, MP. That's what we were looking for. MP is equal to 10. Now we need to find PN. What side corresponds with PN? LK. Okay, so I'm trying to find the measure of PN, so that's going to be X. What is the measure of LK? 3. Again, same scale factor of 2 to 1. Plug in my scale factor, cross multiply. X times 1 is X, and 3 times 2 is 6. So PN equals 6. Again, if you're unsure and you need to trace your lines to make sure, you can put your fingers on one and finger on the other and make sure to trace them both at the same time to make sure that they are corresponding, okay? Also, look at the letter order that each thing is named in to help you make sure you've got the right order. All right, number 8, given that angle CAB is congruent to angle CBD, how do you know that triangle ABC is similar to triangle BDC? So let's take a look. What do I know about triangles about angles A and B? They are congruent, okay? So what do I know about angle C? So notice basically I've got, I'll draw this over here. So basically I've got a big triangle and that is ABC. Whoop, that's B. A, B, C. Everybody good with that? But then I took this down here and I made another triangle. And again, I'm not to proportion, I'm not to scale. But I said angle A and angle B are congruent. So notice if I have angle A of this triangle and angle B of this triangle,
Did you also figure out the problem from yesterday? No.
ooh, I forgot about that. I will look at that this afternoon and send y'all. I meant to do that in my free time yesterday. So it says by the reflexive property of congruence, angle C is congruent to angle C. Because they told us that triangle ABC, I was disregarding, triangle ABC is similar to triangle BDC. So we've just said that A and B are congruent, right? And C is going to be congruent to C, right? So how many angles do I have that are congruent? Two. So what was our postulate that told us that they're similar? Angle postulate. Okay, so again, I disregarded the information they gave me in the very beginning. Don't do that. Make sure you pay attention to what they've given you. The reason they gave it to you is because probably you're going to need it. I'm real bad about just jumping right over what they've given me and try to go with that. All right, so our homework in this section is going to be pages 483 to 485, numbers 9 through 47 odds. So let's look at this for just a minute. Look at 9 and 11. Triangles shown are similar. List all pairs of congruent angles and write the statement of proportionality. So you're listing congruent angles and then you're showing proportional sides. Okay. Look at the next section. So for 13, 15, and 17, you're using your similar triangles to determine either angle measures or sides measures. Okay. Use the proportions that they have given you and solve. Look at numbers 19, 21, 25. Okay, look at each of these. So we can see in 19, I've got two triangles that are similar. Look at 21, again, I've got two separate triangles that are similar, but look at number 23. Now I've got a little, they've put them together, but the main one I want you to look at is number 25. Basically in 25, I'm looking at two triangles in one, but I can use my same proportionality. So I can see that VZ is going to be proportional to VY and VX is proportional to VW. So I'm looking at both of them. If it helps you to separate them and actually draw them separately, that's fine as well, and label them. It's up to you. But we can see that those two lines at the bottom are parallel. Therefore, I've got two separate triangles that I'm dealing with here. Okay. So that was through 25. 27, using labeled points, find the slope of the line. To verify your answer, choose another pair of points and find the slope using the new points and compare the results. So pick two, use your slope formula to find the slope, then pick two more and confirm it. 29 and 31 says to find the coordinates for point E so that triangle OBC is similar to triangle ODE. So again, I have diagonal segments here, but because I have the X and Y axis for each of them, I actually have two triangles, okay? So you're finding the coordinates for point E. You're going to do that. You're just finding the length, okay? Numbers 33, 35, 37. I'm using the figure. I'm using ABCD, which is a trapezoid. And I see that AB is 8, AE is 6, EC is 15, and DE is 10. And I solve for the missing information. 39, 41, 43. Solve for X. Look to see what your corresponding sides are. So you're setting things up where something is equal to something and you're solving for X. And then numbers 45 and 47, the segments in blue are special segments in the similar triangles. Find the value of the variable. So obviously looking at those, you can see immediately that if you need help on that, you're going to go back to example 5. Okay. Use example 5 to help you with that. Mixed review, page 487. Number 61 through 71 odds. 61, distance formula. D equals the square root of, what's my distance formula? D equals the square root of
X1 minus Y1.
Oh, yeah, X.
x1 minus y, or not x1 minus y1. You've got to do
Y2.
Oh,
You've got your X values, the difference of your X values, X2 minus X1, X1 minus X2, it doesn't matter which order, squared plus Y2 minus Y1 squared. So you're finding the difference of the X's squared added to the difference of the Y's squared. Again, another formula that you need for the ACT. So the faster you learn it, the easier it will be. Okay, so distance formula for number 61. Again, if you don't remember it, go back to section 1.3. The next section, triangle mid segments. Remember, mid segments of a triangle is going to be section 5.4. And so M, N, and P are midpoints of the sides of the triangle JKL. Complete the statement. And then lastly, proportions. All right, 8.5, moving right along. 8.5, we are still dealing with proving triangles are similar. So we looked at angle-angle similarity. So now we are looking at two additional ways using side-side-side similarity and using side-angle-side. What does it mean when I say side-side-side similarity?
Yeah, all the sides are similar.
Okay, so side of this one is proportional to the side of this one. The side of this one's proportional to the side of this one. Side of this one proportional to the side of this one. So 3 proportional sides, okay? When I say side, angle, side, obviously I have 2 sides, but where is my angle located in relation to my 2 sides? In between them, okay? So basically, when I do side, angle, side, I'm talking about a side and another side and the vertex that joins them. Okay, so side, angle, side is where I have a side and another side, and then the angle in between them. So side, angle, side. So for 8.5, ways to prove triangles are similar. Number 1 was angle, angle, and we already took the notes on that from 8.4. Number 2, side, side, side. If the lengths of the corresponding sides of 2 triangles are proportional, then the triangles are similar. Draw your side-side example and write the if-then statement. So basically you have triangle ABC is similar to triangle PQR. So you have if AB is proportional to PQ and BC is proportional to QR and CA is proportional to RP prime. Basically the reason they're saying prime is just because you've already repeated P at one point. So anyway, then triangle ABC is similar to triangle PQR.
Was if-then statements studied in algebra 1 or geometry?
Say that again.
Was if-then statements, were they?
If-then was at the beginning of geometry. I think it was in chapter 2. We learned about inverse, converse, contrapositive, and we learned about our if-then statements. So if this happens, then this happens. All right, theorem 8.3, side, angle, side, we already talked about, and it says if an angle of one triangle is congruent to an angle of a second triangle, and the length of the sides, including these angles, so in that blank is including these angles, is proportional, then the triangles are similar. Draw your side, angle, side example, and write your if-then. Good. Put them in a special place where your dog will not eat them. So you're gonna be back online next week. So
I'm making sure.
yep, hide your work from your dog, or just make sure you're feeding it. Bless its heart, it's so hungry, it's having to eat the paper. Just kidding. Just kidding.
Feed your dog.
Poor little dog. All right. So now let's go ahead and look at example 1, proof of theorem 8.2. So they have already told us that RS is proportional to LM, ST is proportional to MN, and TR is proportional to NL. And we're trying to prove that triangle RST is proportional to LMN. So when we look at this, notice that if we look at RS, Well, I'm losing my words. If we look at RS, look at the second figure, and it says to locate P on S. So we can see that PS is equal to LM. What they've done is they've drawn the blue line to show us where triangle LMN would lie directly on top of triangle RST. Okay, so that's what line PQ is telling me there. So I can see that PQ is in that same location as LN. So it says locate P on segment RS so that PS is equal to LM. Then you can draw segment PQ, that PQ is parallel to RT. So now notice that when we have drawn PQ, which is equal to LN, we can see that now PQ is parallel to RT. Seeing that those are parallel, then I can see that triangle RST is similar to triangle PSQ using the angle-angle similarity postulate. And RS is proportional to PS, ST to SQ, and TR to QP prime. We also know that PS, since it's equal to LM, then I can substitute there, okay? So I can substitute PS and LM, I can interchange those. So if I have SQ is equal to MN and QP is equal to NL, I'm using side-side-side congruence here. So I can see that they are similar. And then finally, we've got angle-angle similarity to show that triangle RST is similar to triangle LMN. So basically in this, the whole thing to look at is I could draw side PQ as the same measure of LN to look at where they would be on top of each other. So I could see those two triangles as one. That way I can see what sides correspond with what, to be able to look to see what sides are going to be congruent, what angles will be congruent. So how to show similarity. Let's look at example 2 on page 489. Which of the following 3 triangles are similar? All right, so think about when I'm talking about similarity, I'm comparing 2 things. I cannot compare all 3 at one time. So I would have to compare my first triangle to the middle triangle, and then compare the middle to the last, and then I could also compare the first to the last, okay? So I can look at these. I've got 3 sides of a triangle. So let's go ahead and look at the first triangle and the middle triangle. I have ABC and DEF, okay? So I'm going to compare the first 2. So we're looking, I have triangle ABC, and I'm going to compare to triangle DEF. Okay, so I know that side AB is proportional to DE as long as, what is the measure of AB? What is the measure they tell me of AB? 6. What is DE? 4. What is 6 over 4 reduced to? 3 over 2. Okay, so this is going to be my shortest side. Okay, now I'm going to look at my longest side. What is my longest side of triangle ABC? What's my longest side? AC, because it's 12. What is my longest side of my middle triangle? FD. Okay, or DF, whichever one. So what is the measure of AC? What is the measure of DF? What is 12/8 reduced to simplest form? What are they both divided by?
3,
12 divided by 4 is 3. 8 divided by 4 is 2. So I can see so far I've got the similar scale factors. What about my remaining sides? What is BC?
9.
And then what side corresponds with that?
EF.
Okay, EF is, what is that reduced to?
3 over 2.
Okay,
No.
huh?
Oh.
Divide by 3, divide by 3.
No,
3 over
I
2?
was say- I said no because I thought the bin corresponded.
Okay, so now, when I look at this, I can also compare triangle A to triangle ABC to triangle GHJ. And so go ahead and instead of writing it on the board, we're just gonna go ahead and look at it. Uh-huh,
I will be right back.
okay, that's fine. So it says the ratio of the side lengths of triangle ABC and triangle GHJ. Again, I can set it up just like I'm doing and compare the two triangles, doing the exact same thing we did here, shortest, longest, and remaining side. And I can see when I look at, let's look at those. Triangle ABC and triangle GHJ. Okay, so we've got to look at AB compared to GH. We're going to look at BC compared to HJ. And then we're going to look at AC compared to GJ. What is the measure of AB? 12? Oh, no, 6. What is GH? What is 6 over 6 reduced to? 1 over 1 or just 1? What is measure of BC? 9. What is HJ? 9 over 10 doesn't reduce, does it? All right. What is the measure of AC? 12. What is GJ? I'm sorry? What? 14. Okay, that's what I thought y'all were saying, but I was good. What is that reduced to? 6 over 7. I've got 1 over 1, 9 over 10, 6 over 7. They do not all have the same scale factor, so are triangles ABC and GHJ similar? No, they are not because my sides are not similar. Triangle ABC is similar to DEF, but ABC is not similar to GHJ. The way we did that is we had to set up the proportionality of each side. If they all reduce to the same scale factor, they're proportional. If they do not reduce to the same scale factor, they are not proportional. Any questions about that? All right, let's look at example 3, using side angle side similarity theorem. It says use the given length to prove that triangle RST is similar to triangle PSQ. So when we look at this, again, I have triangle RST and PSQ. So I'm going to set everything up and I'm going to look at, are my sides proportional? So I'm looking at triangle RST and triangle PSQ. All right. So RS is proportional to what?
Yes.
PS. What is the measure of RS? RS.
That would be 16.
RS is 16 because 12 plus 4. Notice that from R to P is 12 and from P to S is 4. They've asked me for RS. So I have to add them together. So RS is 16.
Yes, is 4.
PS is 4. What does that reduce to?
4-1
4 over 1.
or 4.
Okay. Now let's go ahead and take a look. What is SP? Oh, we already broke that down. We already did that together. I didn't show step by step. Okay, what about ST is proportional to what?
SQ.
SQ.
25.
So I've got 20 and 5. What does that reduce to? 4 over 1. Okay. So the lengths of side SR and ST are proportional to the corresponding sides of triangle PSQ because angle S is the included angle in both triangles. Notice that whether it's PSQ or RST, they both have S as my included angle. So I can use side angle side to conclude that they are similar triangles. All right. So it is 10:09. I think I'm gonna stop there. Let's take a look at our notes that we need to fill in. So we're gonna start on page 490. Start page 490 on Wednesday, February, was that the 3rd? Good grief.
Yes, it is.
Okay, Wednesday, February 3rd is where we're gonna start finishing 8-5. So let's go ahead and look at homework. We said our homework for 8-3. So we have homework for 8-3 and 8-4, right?
A2, right?
Huh?
And A2.
If you haven't done 8-2, if you didn't work on that last night, yes, you've got 8-2. Okay, so 8-2, 8-3, 8-4. We'll pick up with 8-5 on Wednesday. If you have questions between now and then, be sure to let me know. Hang on to your notes. Hang on to your homework. So we have homework. The assignment from yesterday was 8-2. Today we finished 8-3 and we did 8-4. So we have, that's our homework due next Wednesday. If you have questions between now and then, let me know. If not, then I will see you guys online next Wednesday.
I'll look it up. We only have 282 pages left to do.
You only have what?
282 pages left.
282 pages left? How about that? All right. Okay, guys, if y'all have any questions, be sure to let me know. And
Miss
I will
Jennifer.
see you guys next week. Uh-huh.
I was just saying bye.
Oh, okay. I'm sorry. I didn't hear the very first part of it. I just heard you say my name. So anyway, all right. Bye. Y'all have a great weekend.
You too.
Bye.
And April, if you're watching this, let me know if you have questions. All right. Bye, guys.
I am Lucas.
He sent out one.